guys, let's talk about the derivatives for exponents, otherwise called the power rule. This is going to be really important. You'll use it in almost every derivative problem you see, so you want to get really good at this one. Let's break it down. We'll start off with some equation, and it could be any variable. We'll say u, right, to the x power. How would we go about taking the derivative for this? Well, you need to remember this rule. So if we have y, we take the derivative. If we start with u to the x, the rule states that we bring that exponent down to the front as a coefficient. So we bring that x right in front of u. So now we would have x times u. And what do we do with the exponent? We subtract 1. So we would have x times u to the x minus 1 power. That would be our derivative. So let's go ahead and apply that. Let's say we have f of x equals 3x to the third power plus 2. What would be our derivative? Well, let's go ahead and take the derivative. So we say f prime x. Let's start with our 3x to the third power. Remember that we said we need to take our exponent, subtract 1, and we bring whatever originally was, in this case 3, out front as a coefficient. So now we have 3, since we had a 3 already there, and then we multiply by another 3 from that exponent, x to the 3 minus 1 power. That would be the second power, right? And if you watched the last video, you know what the derivative of a constant is. So what would be the derivative of 2? It would be 0, right? So let's go ahead and simplify this a little further. 3 times 3 to the x squared is just 9x squared, and we just have a 0 left. So our derivative of 3x to the third power plus 2 is equal to 9x squared. So let's go ahead and do an on-your-own problem. So OYO, let's do f of x is equal to, we'll do a longer one, 4t to the fourth power minus 2t to the third power plus 4t to the second power minus 1/2 t plus 16. So go ahead, you'll get lots of practice using your exponent rule, aka the power rule, on this problem. Pause the video, give yourself a few minutes to try it, and then we'll go through it together. So hopefully you tried this out on your own. Let's do it step by step. If we want to take our derivative, remember we apply the same 2 steps as before. We bring that exponent out front and we subtract 1, right? So now we have 4 times 4t, 4 minus 1 is to the third power now, minus 2 times 3t to the second power, plus 4 times 2t to the first power. And then what about this one, negative 1/2 t? Well, think about what would be the exponent on just t. It would be to the first power, right? So we can apply the same step. We bring the 1 out front, we subtract 1, t to the 0th power. Let's think about that off to the side for a second. Any variable to the 0th power is actually equal to 1, and that applies for anything to the 0th power. It's going to be equal to 1. And so if we think about this, what we now have is minus 1/2 times 1, because we brought the exponent down front, right, times to the 0th power, which is just 1. And then what's the derivative of a constant? 16, that's just 0. So let's go ahead and simplify this a bit, right? We have 4 times 4 would be 16, t to the third power, minus 6t to the second power, plus 8t minus just 1/2, right? 1 times 1 doesn't change the value, it's just minus 1/2, and we don't need to rewrite that 0. So that would be the answer for this derivative. In future problems, you'll probably do this in combination with other derivative rules to get your final answer, so make sure that you know this by the back of your hand. I hope this helps.